Hi, welcome back to the Calculus 1 lecture series. And we are in the unit number 3, application of differentiation. This is the third video for the lecture number 23, the optimization problem. And in this video, we're going to finish the remaining two problems about the optimizations here. Okay, so now let's go ahead and go to our lecture notes here. Okay, so now this is the problem number 4 here. Okay, so let's read the problem. The number 4 tell us, suppose a paint store has determined to sell X liters per day of its base coat primer. It must set its price per liter at 29.5 minus 0.05 X dollars, okay? The store has determined the cost of the stock and the sale those X liters is this much. What should the store set for the price per liter of the primer so that the store maximize the profit? All right, so this one is a little bit different than the previous few problems we did. And it's not like you draw the picture of what is known and unknown, but I think we still can try to see here. We just no picture we can draw here, right? So that's why we said the 6 steps I provide for the optimization is really just a guidelines here. All right, so let's see here. So what is we know? The knowns here is, okay, so they sell the X liter is must set the price at what? The price at this one's here. So I know the demand functions, the P, all right? So this one's here is 29.5 minus 0.5 X. You sell the X liter. So the price per X liter is that, okay? And then we also know the cost functions, right? So we know the cost function. The cost functions here is will be this one's here to store the X square pointer. Okay, I need to be careful. Don't want to put an extra 0 there. So here, this would be 0.2 X squared plus 5.5 X plus 200, right? So this is our cost function. Okay, so let's take a look at what is the unknown. Unknown is how many liters, right? So the X liters. I have no idea. Okay, so I have no idea. The unknown is what? It's a profit. Unknown, right? So those unknown. Okay, so now the number 2 here, we cannot the graph it. So let's just say, how do we connect all these two together? So we know the cost function. We know how much, they want to sell, right? So this is a price when they want to sell here. So I know in order to get the most profit, okay, so let's see here. So profit is what we want to define, right? So the profit is your PX minus what? Is your PX minus, so it's your revenue, okay, I'm sorry. So the profit is how much is your sales, right? So it's revenue. Okay. That will be your revenue minus the cost. Okay, so let's take a look at what is revenue. So for each, whatever how many liters you sell, this is the total, the price per liters, right? So this is the price per liter. So what is the revenue here? So the revenue will be X times the price per liter, correct? So this is how many units you sell. This is the price per liter. Then minus my cost. My cost is 0.2 X squared plus 5.5 X plus 200, correct? Okay, so now in here, this will be the 29.5. This have x here, right? So this is 29.5x minus 0.05 x squared minus 0.2 x squared minus 5.5 x minus 200. Correct? All right, now we just combine the terms here. So x squared term will give you the negative 0.025 x squared, and then plus 29.5, 5.5 plus 24x minus what? Minus 200 here, right? So I want to maximize my profit. All right, so this is my profit. So I say the profit. Profit right now is X. So now that's number 3 is here. I can take the derivative. So profit to the X here. So now the profit to the X, and you take a derivative. So this is 0.5x plus 24, correct? All right, so now you set it equal to 0. So you will get a 0.5x equal to 24. So what is your x? X is 48, right? So that means if you sell the 48 liters, you will get the maximum. Why? Because if you do the profit, if you take the double derivative, will give you negative 0.5. So by the second derivative test, right? So this is a concave down. So by the second derivative test, it will give you max values here. Okay, so now, okay, so I know the x equal to what? 48. That is how many liters. So the price per liter will be the 29.5 minus 0.05 times x here, right? So this will be the 29.5 minus 0.05 times 48. So let's will give you what? 27.110. So that means you're selling the price at $27.10 per liter, and then you will make the maximum profit here. Okay, so this one is a little bit different, right? So they want to see what is the store set for the price. So you know which will maximize the profit, right? So this one is a little bit different than what we did before, but it's follow the same idea. Okay, let's take a look at our last problems here. This one is very interesting, right? So the Gordon is standing on the one side of a canal, and it's 1 kilometer wide. Right, so this is 1 kilometer wide. A lighthouse is 1 kilometer away downstream. So this is 1 and this is 1. Gordon needs to get to the lighthouse as fast as he can, right? So this is what we try to do, as fast as he can. That means I want to do there is as fast as he can. That means the time is what we want to minimize. So what he will do, he will run along the canal part way. So he will run over here and then swim directly to the lighthouse. So write a function Tx for the time it takes to Gordon to make the entire trip. And x is the distance that he runs here, right? And then instead of using we still can use the calculus, but in here is difficult to kind of do the algebra set equal to 0, solve it. That's why it says use the calculator, okay? All right, so now in here, let's take a look here. Also, let's see what is known and unknowns here. All right, so let's see here. The number 1, this is known. So what is known here? Gordon run 4 kilometers per hour. So run is 4 kilometers per hour. Swim is 1 kilometer per hour. Okay, and so we also know in here also we know the distance here, right? The distance is 1 kilometer and 1 kilometer, right? So 1 kilometer here, 1 kilometer here. And the unknowns here is the how many, the x is a kilometer. Gordon, he ran. And so also what is the kilometer he's going to swim, right? Okay, so the last so that's what we don't know here. Okay, all right, so now let's try to kind of put this into a better graph, so we will be able to solve that. Okay, so here let's take a look here, right? So this is the one, so this is x here, this is the lighthouse. Let's put it directly here, so that if he runs all the way, then he swim all the back here, right? So, but now he run the x. So if this is x, so what is this distance here? This distance is 1 minus x, correct? This distance is 1 minus x. So what is the distance he swim here is y, correct? And then this one here is a fixed distance, it's 1 kilometer. So now we know here, okay, so we can write in here. So the kilometer he swims. So what is the kilometer he's going to, the x kilometer is he's going to run. So how many kilometers he's going to swim is the y. Okay, and now, so after you redo that, I think, okay, so I think it's a little better here, right? So now let's take a look. This is step number 2, and then we already labeled we redo the graph. So let's take a look at step number 4. So what is the relation? Okay, so the relation here, this one here is pretty easy relations, right? So it's a Pythagorean series. So it's y squared is equal to 1 plus 1 minus what? X squares here. Okay, now the number 5 here. So also we don't know the times, right? So it's times, we'll put a tx here. So the times here, okay? Let's take a look, how do we, the time. Okay, the times is the time, we have 2 elements, right? So times of running plus the time of what? Swimming, right? So you need to combine the times of the running and the time of the swimming. Okay, so let me color coding that, so maybe we can see the idea. So how much time is going to take for the run? Now let's relate it to here. We said run, every hour I can run 4 kilometers, right? So X distance. So 1 hour you can have 4 kilometers. So if you run X distance, what is this one here? It's X over what? It's X over 4, right? Depends on what is the distance you're going to run. So it's X over 4. And then also it say the time you go to swim, the time you go to swim is 1 kilometer per hour. So what is the time you're going to swim here? Okay, so for the swims here, right, it's the y's, right? So I know the y is the square roots of 1 plus 1 minus x squared. But this is the distance, but it's 1 hour, so you divide it by what? You divide it by 1. So I want to what? I want to minimize. These numbers here. So this will be my times, right? So this is x4 plus 1 plus 1 minus x squared. So of course, number 6 here, we say, hey, you still, can do the t prime x and set equal to 0 and then solve for x. But this one here is not easy to solve. So that's why we will use the, we will use the graphing calculators and try to help you to see, how do you solve this ones here. All right. So now let's go back. So let me show you how to use the graphing graphing calculators. So let me go to the graphing calculator part here. Okay, so now you can just type in the function. You say y is equal to the x over 4. All right, then plus, all right, so the plus is the square root, and then here this is 1 plus 1 plus 1 minus x. All right, and to the square. Okay. All right. So now you get this graph here, right? So like I said, it's probably difficult to use the to use the calculus to try to do that. So as you can see, they automatically, so because I know my range is here from 0 to 1, the x is from 0 to 1, right? So here, that's why it will give you the minima numbers here. So the x equal to the 742, then is 1.218 here. Okay, so that's why let's go back to our lecture notes here by the graph. So by the graph, you will see the minima points will happen at x equal to 0.742. That means for Gordon, it's the best for, it's the best for him to run 0.74 kilometers, and then the rest of it go swimming. And so this will give him the faster time. So what is the times here? So times is 1.218 hour. So it's so it's about 1 hour 15 minutes, right? Okay, that's it. We had 3 videos to talk about 5 different type of the optimization problems, and I hope you got a pretty good understanding how to do the optimization problems, right? So follow the 6-step guidelines and identify what is known and unknown, and then combine them. The key things here is change all of them to one variable to the quantity you want to maximize or minimize. All right, that's it. Okay, so it's a nice talk to you. And now the next, we're going to start the integration part. Okay, bye. Have a good day.